So let us see the centripetal acceleration using the calculus method. So now our particle starts from this position. Let's call it A. Suppose it goes to the point B, and suppose it is performing uniform circular motion. Okay, it's performing uniform circular motion. So I can define the angular velocity for this particle, right? So suppose it moves from here to here. So this angle from position A to position B, suppose it's equal to theta. So we can say omega is equal to what? Theta upon t. Omega is equal to theta divided by t, and therefore we can write theta in terms of omega. So theta equals to omega times t. This thing we can write. Okay, so this is the starting position vector of our object. Position vector at some time t becomes this one. Okay, let's call it r bar, right? And now what I will do is I will resolve it along two perpendicular components, along x-axis and along y-axis. So let's resolve this. So this is my origin. This is my origin. Okay, this is the x coordinate. This is y coordinate. Okay, x and y-axis. So let's draw a perpendicular from here on x-axis and y-axis. Okay, so this much is my x component. So I will call it Rx, and this is the y component. I will call it Ry. So what can I say about the position vector? R bar is equal to Rx times I cap plus Ry times j cap, right? And how can I write Rx and Ry in terms of R? So Rx will be R cos theta and Ry will be equal to what? R sin theta. Okay, so this is R cos theta multiplied by I cap plus R sin theta multiplied by j cap. And what is theta? Theta is equal to omega t. Okay, so you get R cos omega t multiplied with I cap plus R sin omega t multiplied with j cap. This is the position vector of a particle performing which motion? Uniform circular motion. So please remember this. There have been questions based upon only this much. Okay, this much topic, this much theory, you can say. So there have been questions based upon only this thing. Okay, in the NEET exam. So please remember this. This is the position vector of a particle performing uniform circular motion. Okay, it is R cos omega t multiplied by I cap plus R sin omega t multiplied by j cap. Right. So after that, to find velocity of this particle, we will take derivative with respect to time. So dr bar by dt is equal to. So if I take its derivative, I can take r common. Okay, so it is d by dt of cos of omega t multiplied by I cap plus d by dt of sin omega t multiplied with j cap. Okay, so now tell me what will be derivatives. What is derivative of cos omega t with respect to t?
Minus sin of omega t.
Minus sin omega t multiplied by omega. Right, I am taking derivative.
Yes, sir.
Yes, sir.
Okay, I am taking derivative with respect to t. So here you have omega t, not t. Okay, so you will have one omega in multiplication. Okay, using the chain rule. So you get dr bar by dt or v bar is equal to r multiplied by omega multiplied by minus sin omega t into I cap plus omega multiplied by cos of omega t. So it is derivative of what? Sin of omega t is cos of omega t multiplied by omega. Okay, so omega cos omega t multiplied with j cap. Okay, then you can take this omega out. So you can write this as r omega and minus sine omega t multiplied with I cap plus cos of omega t multiplied with j cap. Okay, so here you get the magnitude of velocity is equal to what? It is equal to r multiplied by omega, right? And now I want to find out acceleration. So I will take one more derivative, right? So let's take one more derivative. So taking one more derivative, we get acceleration a bar is equal to, we can keep r omega as it is, okay, multiplied by what? d by dt of this thing and this thing, okay. So it is minus sign I can take out, d by dt of sine omega t multiplied with I cap plus d by dt of cos of omega t multiplied with j cap. Okay, so now what is derivative of sine omega t? Omega cos of omega t. What is derivative of cos omega t? Minus sine omega t multiplied by omega. Okay, so you get one more omega out, right? I can take it out. I will write it like this. It is r omega square, that omega multiplied by this omega, multiplied with minus cos of omega t multiplied with I cap. Okay, derivative of this is cos of omega t multiplied with omega. That omega I have taken out. Okay, plus derivative of this thing is minus sine omega t. Okay, so it is minus sine omega t multiplied by j cap. Okay, and now what you can do is you can take minus sign common from these two terms. You can move r inside and you can write it as, this is minus of omega square multiplied with r cos omega t multiplied with I cap plus r sin omega t multiplied with j cap. So what is this? Tell me.
Position vector.
This is position vector, right? R cos omega t into I cap plus r sin omega t into j cap is the position vector. So you get acceleration is equal to minus of omega square multiplied with r bar. Okay, and which acceleration is this? Can you tell me? This is centripetal acceleration, this is total acceleration, or this is tangential acceleration? Which one is this?
Centripetal.
Reason? Okay, your answer is correct. This is centripetal acceleration. We are deriving centripetal acceleration only. So where did we confirm that there won't be any tangential acceleration? In which of these steps did we confirm that there won't be any tangential acceleration? When we considered that the angular velocity is going to be uniform, right? If angular velocity is uniform, then v is equal to what? Magnitude of velocity is r multiplied by omega. Got this?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, we are defining angular velocity at the beginning. Sorry. We are defining angular velocity at the beginning. So at that step only, that step itself, we are saying that okay, omega is going to be our constant, and theta, how does theta vary? This constant multiplied with time. Okay, some constant multiplied with time. So how is our theta changing? It is changing uniformly. Okay, it is changing uniformly with respect to time. So omega is our constant, and that confirms that velocity, the magnitude of velocity is going to be a constant. So if magnitude of velocity is constant, there won't be any tangential acceleration. Okay, so the acceleration that we are getting is only centripetal acceleration. Okay, this is only centripetal acceleration. So I will put suffix c over here. Okay, so this is a real quick method of deriving centripetal acceleration, the calculus method. Only two derivatives, that's it. Okay, the job is done, right? Just like we have kinematic equations in linear motion, we can have kinematic equations for circular motion too. So all the quantities like linear acceleration, linear displacement, linear velocity will be changed to their angular counterparts. Okay, so linear acceleration will change to what? Angular acceleration. Linear velocity will change to angular velocity, so on and so forth. Okay, so we can very easily derive that, but we won't derive it. So these are, we have three kinematic equations: v equals to u plus at, s is equal to ut plus half of at square, and v square equals to u square plus 2 times a into s. These are our kinematic equations for linear motion. For angular motion, let's suppose omega naught is the initial angular velocity. Okay, omega t is angular velocity at some time, angular velocity at time t. So we know alpha, the angular acceleration, can be written as what? Omega t minus omega naught divided by t minus 0. That is t. And from here we get the first kinematic equation. So omega t so from here we get the first kinematic equation, that omega t is equal to what? Omega naught plus alpha t. Okay, take t on other side, will be alpha t. Take minus omega naught on other side, it is plus omega naught. So this is first kinematic equation, and it is exactly similar. It is exactly similar to what? V equals to u plus at. Just final velocity will change to what? The final angular velocity. Initial velocity changes to initial angular velocity. A changes to alpha. T remains t. Okay. So can you tell me what will be the second one? Can you guess? S will change to, S is linear displacement. Yes.
Angular displacement.
Angular displacement. Right. The angle covered. Theta is equal to omega naught multiplied by t plus half of alpha multiplied by t square. This is second kinematic equation. Okay, and then we have omega t square equals to omega 0 square plus 2 times alpha theta. Okay, so v square equals to u square plus 2 times as. A changes to alpha, s changes to theta. Right, it's very simple. So this is second kinematic equation, this is third. So is it clear? So see this question. The position vector of a particle is given by this thing. Okay, and tell me the answer. Option, the velocity vector of the particle is parallel to position vector, perpendicular to position vector, directed towards the origin, directed away from the origin. Yes. Okay, this is position vector of a particle performing what? Which kind of motion?
Uniform circular motion.
Uniform circular motion. Okay, and in circular motion, what is direction of velocity? What is direction of velocity? Let's suppose your object is here. What is direction of velocity at this point if it is performing circular motion? Is it along the tangent? Okay, this is the position vector, this is the velocity vector. How much is the angle between them?
90 degrees.
It is 90 degrees, right? The velocity is tangential, position vector is radial. What is angle between radius and tangent? It's 90 degrees. When object moves to this point, okay, the position vector will be this one. The velocity vector will be directed like this, right? So angle will remain 90 degrees. You got this? What is the answer then?
Yes, sir.
Perpendicular to
What?
position vector.
Perpendicular to
Perpendicular to
position.
position.
Okay, this is the answer. Very simple. Okay, let's move on to next question. A particle moves so that its position vector is given by r equals to omega t multiplied by x cap. X cap is your I cap plus sine of omega t multiplied by y cap, where omega is constant. Which of the following is true? Tell me. This is slightly different but similar question. Okay, so velocity and acceleration both are parallel to r. Velocity is perpendicular to r and acceleration is directed towards origin. Velocity is perpendicular to r and acceleration is directed away from the origin. Velocity and acceleration both are perpendicular to r. Which one? Velocity is perpendicular. That you know. Yes, Sanjay?
Option C, sir.
Velocity is perpendicular to r and acceleration is directed away from the origin. Acceleration is directed towards the origin, no? Towards the center of circle. In circular motion, what is direction of acceleration? The centripetal acceleration.
Yes, sir.
Okay, it is along the radius towards the center. So which option?
Option B.
Option B is the
Option
answer.
B, sir.
Okay, is it difficult?
No, sir.
Not at
No,
all.
sir.
Okay, this is from NEET, I guess 2016 or something. Okay, next question. Again, the radius, the radius of circle, the radius of circle, the period of revolution and initial position and sense of revolution are indicated in the below figure. Okay, so can you see this figure clearly? Shall I zoom it? Now can you see?
Yes, sir.
Okay, so
Yes,
particle
sir.
starts from here, right? It starts from here. Okay, and it's moving in clockwise sense, not in anti-clockwise sense. So the y projection of radius vector of rotating particle p is, tell me. Okay, you want to see the options? What is radius? 3. So it is r sine or cos. Okay, right? So 4 cannot be the answer. See, the object starts from this point, it moves like this. Okay, clockwise sense. So suppose your object moves here. Okay, this will be your radius vector, right? How much would be this angle? This is theta. Suppose theta will be equal to omega t. We have seen this.
Yes, sir.
Okay,
Yes, sir.
and now I draw a perpendicular from here on y-axis. I want y projection. Okay, so I will draw a perpendicular on y-axis. So what will be this y projection? This y, it will be r cos theta or r sin theta. This is your r. Tell me. R cos theta. Okay, please remember this. If you are going through the angle, it is cos component. If you are going away from the angle, it is sine component. Okay, through the angle, cos component. Away from the angle, sine component. So this is cos component. Okay, so it is y is equal to what? Y is equal to r cos theta, and theta is omega t, right? So now tell me. So its time period is given. Time period is equal to 4 seconds. So how much would be omega? Omega is equal to 2 pi by t, right? So it is 2 pi by 4, right? So it is pi by 2. Okay. So in place of omega, you will substitute pi by 2, right? In place of omega, you will substitute pi by 2. Okay. So now which is the answer?
Option C.
Option C is the answer. Okay. So this is clear,
Yes,
Yes,
sir.
sir.
everybody?
Yes, sir.
Okay, good. So okay, so this is also a simple question. Let's see next one. A particle starting from rest moves in a circle of radius r. Okay, it attains a velocity v naught meters per second in nth round. Okay, which round? Nth round. Its angular acceleration will be. So what do we have to use here? Kinematic equation,
Yes, sir.
right? Which one?
B square equal to U square plus 2AS.
Okay, v square equals to u square plus 2as. We can use that, right? But we are asked about the angular acceleration. Okay, yeah. So we can use v square equals to u square plus 2 times a multiplied by s. Okay, and from there also we can find out, right? So what will be a then? A particle is starting
Option D,
from.
sir.
You solved? Good. It might be the answer. Let us check. Okay. So it attains velocity v naught in nth round. So s will be equal to what? The distance covered in one round.
N into 2 pi.
Good.
2 pi r.
N into 2 pi r. So distance covered in one round is 2 pi r. So in n rounds, it will cover n into 2 pi r. So 2 times a multiplied by n into 2 pi r. And this is tangential acceleration. Okay. So v, this is v naught square. And now you can write this tangential acceleration is what? It is r multiplied by alpha. Okay, so it is 2 multiplied by r into alpha multiplied by n into 2 pi r. So this 2 times 2 is 4. So you get alpha equals to, sorry, v naught square divided by 4 pi r square. No, 4, what
4
happened?
pi n r square.
4 pi n r square. Okay, you get v naught square divided by 4
Option
pi n
C.
r square. Option C is the answer. Let's move on to the next problem. The next problem is a wheel is rotating at 900 rpm about its axis when the power is cut off. It comes to rest in 1 minute. The angular retardation is. This is very simple, right? So final angular velocity is 0. Initial angular velocity is 900 rpm. You have to convert this to radians per second. So you are given basically with n, okay, number of revolutions. Okay, so this is n is 900 rpm. So convert it to rps. So 900 divided by 60 rps, that is So 90 by 6, 15, right? Okay. And then it comes to rest in 1 minute. It comes to rest in 1 minute. So time is equal to 60. Okay. So then what is alpha? So omega naught is equal to 2 pi times n, right? So then alpha will be equal to omega t minus omega naught divided by this time. Okay, it comes to rest in 60 seconds. So let's substitute the values. So omega t is 0. It is minus of omega naught is 2 pi multiplied by 15 divided by 6. 60. What's the answer? Pi by 2. Okay, for a particle in uniform circular motion, the acceleration a bar at a point P on circle of radius r is measured from x-axis is, tell me, here theta is measured from x-axis. What will be the answer? Okay, so we have seen this, that the centripetal acceleration, okay, since it is performing uniform circular motion, acceleration will be the centripetal acceleration. Okay, so what is centripetal acceleration? So in terms of particle performing uniform circular motion, acceleration a at point P are not on the circle of radius r. Okay, here theta is measured from x-axis. Theta is measured from x-axis. Okay, so what will be the centripetal acceleration? Can it be this one?
Minus omega square r. Yes,
Minus
sir.
omega square r. Okay, we'll write capital R. Okay, multiplied with r cap, right? And r cap is equal to what? So this can be written as minus omega square r or v square divided by r. Okay, so this can be written as v square upon r also. Multiplied with r cap is cos of omega t multiplied with I cap plus sine omega t multiplied with j cap. So centripetal acceleration is this, right? So you get answer. Okay, so in place of omega t, you write theta. That's the angle covered, right? In place of omega t, you can write theta. Yes, no?
Yes, sir.
Okay,
Yes, sir.
this is your circle and this is your particle, which is performing uniform circular motion. Okay, and you want to measure its acceleration from the x-axis. You want to measure its acceleration. Okay, and this theta is the angle with respect to x-axis. So this theta will be equal to omega t. So this is its position vector. You can resolve it in two components, one along x-axis, one along y-axis. So this will be what? R cos theta. This will be R sin theta. We have seen this. Okay, so this is equal to what? So it is R cos theta. R bar can be written as R cos theta multiplied with I cap plus R sin theta multiplied with j cap. Okay, so so acceleration is what? It is minus of omega square multiplied with r bar. R bar is this, and you can take that r common, and you can write omega square r as v square upon r. So it will be equal to minus of v square upon r multiplied with this thing, cos theta into I cap plus sin theta into j cap. Okay, so this is the answer. Option C is the answer. Right, this is simple. Next question. A particle moves along a circle of radius, this is the radius, with constant tangential acceleration. If if the velocity of particle, they are saying. Okay, I guess this is if is 80 meters per second at the end of second revolution. Okay, after motion has begun, tangential acceleration is. So this is simple, right? Might be calculation heavy. Let's see. So which formula will you use? You are given with r, radius is given, it is 20 by pi meters. The initial velocity is given, it's 0 meters per second, right? Or let's call it u only. Okay, and v is given, it is 80 meters per second at the end of second revolution. That means which another thing is given? 2 revolutions. That means total distance covered is given, s is given, right? S is equal to 2 multiplied by 2 pi r. Distance covered in one revolution is 2 pi r. Distance covered in two revolutions, 2 times 2 pi r, right? So which formula will you use? Okay, you have initial velocity, you have final velocity, you have displacement, okay, and you want to find out the acceleration. So you will use v square equals to u square plus 2 times a multiplied by s. So this is 0. Okay, u square. So u is what? 80. So let's keep it as it is, u square plus 2as. Okay, so you can say minus 2as is equal to u square, and therefore s is equal to u. You want what? A. So a is equal to minus of u square divided by 2 times s. It is 80 square divided by 2 times. How much is s? S is this thing, 2 multiplied by 2 pi r. Okay, so 2 multiplied by 2 pi r. Okay, so what would be the answer? You want tangential acceleration, right? And radius is given. Okay, so radius is how much? It is 20 by pi. So let's substitute that. So it is minus 80 square, and you can cancel out that with this. Okay, so 80 square divided by 4. So it will be 20 square multiplied with 4. Okay, no, 40 square multiplied with 4, and this 4 will get cancelled. Okay, so minus 40 square upon, you have 2 pi multiplied with radius is 20 by pi, right? So this pi and pi gets cancelled. So in denominator you have 40, numerator you have 40 square. So answer will be 40. So minus 40 meters per second square will be the answer. Okay. So this is simple, right?
Sir, initial velocity 0, sir. For substituting.
Oh, initial velocity, particle moves along circle of a radius, this thing, if velocity of particle is 80 meters per second. Initial is 80. Initial is 80. So here I did a mistake in writing. Okay. Final is 0. Velocity of particle is 80 meters per second. No. Okay. Here it's correct. Here it is wrong. It is accelerating, not decelerating. Okay. So there is a negative sign. Okay. So this will be 0. And this is 80. 80 square. Sorry. Okay. This is v square. So this will be v square. There is a difference of negative sign only. Okay, so here also it will be v square, right? There will be difference of negative sign only, so it will be positive, 40 meters per second square. Next question. a particle moves such that its position vector r at time t is again the same thing, okay, where omega is constant and t is time, then which of the following statements is true for velocity v bar and acceleration a bar of the particle? So see, this is from JE, this is not from NEET, okay, but it is similar question. Or is it the same question? Tell me the answer.
Yes, sir.
What is the answer?
Option D, sir.
Option D. V is perpendicular to R bar and A bar is directed towards the origin. Right. This is the answer. All right. So let us solve this. So particle is moving along circular path with constant speed 10 meters per second. What is the magnitude of change in velocity of particle when it moves through an angle of 60 degrees? So let's suppose initially your particle is here. Okay, initially the particle is here. So its velocity will be in this direction, suppose. Okay, and then I'm sorry, this direction. Okay, then it moves through an angle of 60 degrees. It moves here. Okay, angle of 60 degrees, right? So this is 60 degrees, and now the velocity is directed in this direction, tangential. Okay, this angle is 60 degrees. This angle is 60 degrees, and now you are asked to find the change in velocity. What do you have to do? You have to subtract this initial velocity, you can call it Vi or V0, from Vt. Okay, so how to do that? Take this vector, put it over here. Okay, put it over here. Okay, sorry, this is your V0 and you want to subtract it. This is V0 bar. Okay, so how much is this angle? This is 60 degrees, because angle between radius is 60, it moves through 60 degrees, so this angle will be 60. So how can you subtract this? You can draw minus V0. Okay, so this is Vt, velocity at time t, minus V0. How much would be angle between this thing, this V, and minus V0? If this is 60 degrees, how much would be this angle? 120 degrees,
120.
right? So now you want to add this vector and this vector and find out the resultant. Okay, so what is delta V bar? The change in velocity. Okay, how much is delta V bar? It is V bar minus V0 bar, right? It is V bar plus minus V0 bar. Okay, so this vector plus this vector. Okay, so how can you find out the magnitude? You have parallelogram law. You have parallelogram law, right? So delta V equals to square root of, the speed remains constant, but let's write it, V square. Okay, V square plus V0 square plus 2 times V into V0 multiplied by cos of the angle 120 degrees. Cos of 120 degrees. Okay, right? And the speed is same, right? Speed is constant. That means the magnitude of V and magnitude of V0 is same. So see, this will be, I can say this is equal to V only. Okay, so it is 2V square plus, what will be cos of 120 degrees? What is
1 by 2.
1 by 2 or minus 1 by 2?
Minus 1 by 2.
Minus 1 by 2.
Minus 1 by 2. Okay, so it's minus 1 by 2 minus 1 by 2 multiplied by 2V square. So this is just square root of V square, because this will be what? Minus V square. So 2V square minus V square is V square. and you have square root of that. So it's equal to v, right? The magnitude of speed. How much is that? It is 10 meters per second. Okay.
Yes, sir.
Yes, sir.
So let's see this next question. Car is traveling with linear velocity v on a circular road of radius r. If its speed is increasing at rate of a meters per second squared, then the net acceleration will be a means. Tell me. Speed is increasing at rate of a meters per second squared. So which acceleration is this? Which is a? Is it tangential? Is it centripetal? Is it total? Okay. So speed is magnitude of velocity. You know this?
Yes, sir.
Okay.
Yes, sir.
And it is increasing at the rate of a meters per second squared. That means magnitude of velocity increasing at the rate of a meters per second squared. So which acceleration changes the magnitude of velocity? Tangential or centripetal? Centripetal acceleration changes which thing? Centripetal is due to change in direction of velocity, right?
Yes, sir.
Yeah. So which acceleration is this?
Tangential acceleration.
This is tangential, right? Okay. This is changing magnitude of velocity, no? So this is tangential acceleration. Okay. So A is tangential acceleration. Okay. And now, what is net acceleration? We know what is net acceleration. The square root of AC square plus AT square. So AT square is given to be equal to A. What is AC? V square upon R. So it is V square upon R square plus A square. This is the net acceleration, magnitude of net acceleration. So answer is option C. Simple.
Yes,
Yes,
sir.
sir.